Hello friends, welcome to Shiksharthi. In this video, we shall be discussing the basics and concepts of circular motion of time, distance and speed. So let's start. Now, this gives me an opportunity to talk to you that you should have watched all the videos on linear motion before you come down to circular motion, because most of the concepts that we have already discussed in linear motions are applicable to circular motion as well. So just to start off with a basic difference between the two, when I talk about a linear motion means a line, a straight line. And when I talk about a circular motion means circle, right? Okay, so now these are some of the concepts that we have already discussed. I'll just quickly go through them. So one is, if there are two objects moving in the same direction, then we subtract their velocities. If there are two objects moving in opposite direction here means we are talking about moving towards each other. The second thing here could be they are moving in a circular motion away from each other. So when we are talking about opposite direction, one is moving towards each other or moving away from each other. In either of the cases, you have to add their respective velocities, individual velocities. Time taken to meet on the circle, we can apply the concept of relativity, because this entire discussion that I am doing today is only with respect to relative velocity, right? And maybe some other concepts if time permits. Last but not the least, we have already talked about that if I take the ratio of the velocities, now keeping time constant, this will be equal to the ratio of their displacements, which will be equal to, now if I compare velocity with time, so we know that velocity is inversely proportional to time, keeping displacement constant. And this is equal to the number of rounds taken, directly proportional. And why have we brought number of rounds? Number of rounds in a certain sense is the distance or the displacement that is being covered. So velocity or speed is directly proportional to the number of rounds taken by that individual who is either walking or running or doing whatsoever, right? These are few concepts that we'll be using. Now in this session we'll be focusing about, there are two objects moving in the same direction. There are two objects moving in a circular track, and we'll be focusing upon they'll be moving in the same direction. So let's say there are two objects or two entities A and B. So we are talking about moving in the same direction. So we are talking about first part of it, the first part, moving in the same direction. In this we will basically talk about first thing, meeting at the starting point. And the second thing that we'll be talking about here is meeting at any other point other than the starting point. I repeat, in this session we'll be focusing about there are two entities or there are two objects moving in a circular track given the dynamics of the track. So when I talk about given the dynamics of the track, so some piece of information will be given to you. For example, what is the piece of information that I am borrowing here is, let's say the speed of A is 6 meters per second. Speed of B is 2 meters per second, right? And let's say the length of the track, which I can take it as either distance or displacement. So let's say the relative length or the absolute length, does not make much of a difference here, because they are running on the same track. So let's say this is given to you as 1000 meters. This is the piece of information that is given to you. So the second thing that we'll be discussing here is meeting at any other point other than the starting point. Now this other point will not be the starting point. This is what we are going to discuss broadly. Okay. Now, so let's first focus, and then we will be using two concepts as we have been using in linear motions also. The first concept that we'll be using here is ratio, proportion and variation. Second concept, we'll be using the concept of relativity, which is relative velocity. Okay, so can I say that the ratio of their speeds, which is SA upon SB, in this case is how much? 6 by 2, which can be written as 3 upon 1, which can further be written as this is the time taken by B versus time taken by A ratio, which is equal to the distance traveled by A divided by the distance traveled by B, which is equal to the number of rounds traveled by A in a given time divided by the number of rounds traveled by B in the same time. It's just like saying speed is directly proportional to the number of rounds covered by those individuals, keeping the time constant is what we are talking about. And all these ratios, they are equal to 3 by 1. The second thing that you need to understand here is, since they are moving in the same direction, now when there are two or more objects or individuals or entities or bodies whatsoever moving in the same direction, what do? We subtract their velocities. Okay, now please see this very carefully. This I could have written this as 6 by 2, but please convert the ratio in a coprime ratio. What is a coprime ratio? If I talk about the HCF of the numerator and the denominator, when it is equal to a 1, it is then we talk about a coprime ratio, or the simplest form of a ratio. Now, what is the simplest form of a ratio? The simplest form of a ratio says that the numerator and the denominator should not have any other factor common other than 1 itself. So, have we converted this into a simplest ratio? Yes, we have. Now, the moment you convert this into the simplest ratio, the second thing that you need to do here is, how much is SA minus SB? This is 2. So, now this is the concept that we are discussing. We are not discussing any short tricks. I have never used any word like short tricks in my videos because we don't want you to embark upon short tricks. There's nothing like short tricks. So this is a concept that we are discussing. What is the concept? The concept here is theory of relativity, which says if there are two or more objects moving in the same direction, identify the slowest and then subtract the velocity of the slowest from the others. Incidentally, here we have only 2. So in that case, how much is 3 minus 1? 2 units is what you're going to do. The moment you get this as 2 units, divide this circle into 2 parts. And divide this circle into 2 congruent parts is what I am talking about. So one part is the starting point itself. Let us put it as S dot P dot. And this is any other part other than the starting point. So if you recall, we talked about some topics which are very important for a topic like time, distance and speed, which I have already talked about it in my earlier videos. You can refer to it. And one of them is geometry. So now we are going to integrate geometry with this. Once we have done this, you will see that this circle gets divided into 2 equal parts. Let us symbolically identify it like this. Once you have identified this, the next thing which I am suggesting you to do here is, what is the total distance here? So can I say the total distance is 1000? So in that case, if I say that this point is X, let me put the starting point as X, and let me put this point as Y. So can I say this side, and let's take this point as Z. I'm not taking point. So let's say this arc, I'm talking about the arc X, Z, Y, and the other arc that I'm talking about is, this is not a point, this is just symbolic of this arc is equal to this arc. Okay, so now once I've done this, so let me take this as W. So what we are saying here is the arc X, Z, Y is equal to the arc X, W, Y is what we are saying. This is the part of the concept which we are discussing. Okay, once we use these 2 concepts, now it becomes fairly easy. Now fairly easy to do what? Let us talk about that. Now in that case, I will not start off with the starting point, and maybe I'll say that this is more important than talking about the starting point. And incidentally, to start with this, what I will say here is meeting at any point. So the third point that I'm bringing here is meeting at any point. On the track. This is the most important part, because part A and part B are the subsets of this discussion that I am doing with you. So, talking about meeting at any point on the track, let's start with this. So when we start with this, we see that now when we talk about meeting at any point on the track, we are basically talking about theory of relativity, right? So let's say that the time taken to meet for the very first time is denoted by T of m1. So this will be equal to what? The relative distance of separation, which is 1000 meters, divided by the relative velocity. And the relative velocity is how much? This will be SA minus SB. So when we are talking about SA minus SB, we are basically referring to what? We are referring to 6 minus 2, which is 4. So that means the very first time when they would be meeting each other would be after 250 seconds. So now the next thing which is very important here is, once you know that they'll be meeting now after every 250 seconds, so you will see that point number A and point number B will also be taken care of. I mean it. So among A, B, C, the most important discussion is when would they meet each other when they are, during the course of their motion. So can I say that they'll be meeting after every 250 seconds? This is absolutely correct. But now the point which is equally important here is, what is the distance covered by A when they would have met for the very first time? Is just like saying distance is velocity into or speed into time. So the speed for A is 6, the time is 250 seconds. That means the very first time when they would have met, A would have covered 1500 meters, and in the same time the distance covered by B would have been, when they have met for the very first time, is how much? 2 into 250, which is 1500, which is 500 meters. So from here, if I wish to see that the ratio of the distance should come out to be 3:1, which it is. Right? Now, taking this discussion forward, if I'm interested in knowing that the second time when they would be meeting each other, can I put it as T of m2, which will be nothing but a multiple of, so this I can say is 250 into 1 seconds. This becomes 250 into 2, which is 500 seconds. So the second time when they are meeting each other, so let's say this is the second time when they are meeting each other, this is the first time when they were meeting each other. So next time when they meet each other here would be the third time, next time would be the fifth time, and so on. And here I can say this is the second time, the next time when they'll be meeting at the starting point would be the fourth meeting point, then the sixth meeting point, and so on. This is what we can extrapolate from here. So can I say that the second meeting point would be after 500 seconds? Similarly, can I say that the third meeting point will be after 750 seconds, and so on. And then if I wish to extrapolate, I could have said that the nth meeting point would be after 250 into n seconds, where n refers to the nth time when they would be meeting each other. Maybe the first time you put the value of n as 1, so n here is a natural number. Please remember this. Now once you have done this, then this discussion becomes fairly easy. Fairly easy means, let us say this is the first time when they are meeting, second time, third time, fourth time, fifth time, sixth time, and so on. So can I say they'll be meeting at they'll be meeting the first time after 250 seconds? That is correct. Second time they'll be meeting after 500 seconds. Third time they'll be meeting after 750 seconds. Fourth time they'll be meeting after 1000 seconds, and so on. And here I can say that the ones which I'm encircling here, these are nothing but the starting point, and the ones that I have not circled here, maybe I'm ticking, these are the points which are other than the starting point. So it becomes very easy with the help of theory of relativity to estimate their meeting points, the time at which they would be meeting at a particular point, or for a particular meeting point. It becomes very easy. Alternatively, now once you know that it is all a play of multiples, then alternatively you can use a method which says, if I wish to calculate what is the time taken by A to complete one full round, it's just like saying 1000 divided by 6, which is 500 by 3. Similarly, if I have to calculate that the time taken by B to run one full round will be 1000 divided by 2, which is 500 seconds. And I know from theory of relativity that it is all multiple concept. So now from here, if I take the LCM of both, so I'm suggesting what? Take the LCM of the individual times taken by them. So when you take the LCM of a fraction says what? You take the LCM of 500 and 500, which is the numerator, which is 500, and then you divide it by the HCF of the denominators. So HCF of 1 and 3 is 1 itself. So when you take the LCM, you will be saying that they'll be meeting at the starting point after every 500 seconds, which we were able to certify from here itself. So ultimately, you need to understand that when they are moving in the same direction, right, you will first convert the ratios into the simplest form, which we have done here. Then you will subtract those ratios, and those ratios, the subtraction, the figure that you get here, you will divide the circle into those many congruent parts. Once you have done that, then it becomes easier for you to see how many times would they be meeting. So if I would say how many times would they be meeting, they'll be meeting at 2 different points on a circle. I mean, how many times would they meet? They would be meeting n number of times, but the points at which they'll be meeting on the circular tracks would be only 2 points, 2 unique points at which they would be meeting each other, right? And then the remaining discussion that we have done here. If you feel that this video takes, it is so informative that it takes your learning to a next level, please do not forget to like, share and subscribe to our channel. If you have already done so, click on the bell icon and select all so that you get regular updates from us. If you want us to do videos on such type of topics, do not hesitate and put it in the comment section so that we can do it in a fantastic manner for you. Thank you so much. Until next we meet, goodbye.